Good day, everybody. For this video, I am going to talk about two-dimensional kinematics. We already talked about one-dimensional kinematics, and when we talk about one-dimensional kinematics, we talk about the straight line motion only. So we either talk about motion in the x direction as our example from our previous discussions, and we also have a motion in the y direction. More specifically, we talk about free fall. Free fall is a motion that is only affected by the gravity of the Earth, right? We talk about the value of the acceleration due to gravity, which is 9.8 meter per second square, as this is the average value of the acceleration due to gravity on the surface of the Earth. For today, we are going to talk about two-dimensional kinematics, and for this one, we are now going to talk about motion with x component and y component. So simultaneously, the object is moving uh, with x and y at the same time, right? Shown on the figure is an example of a two-dimensional motion. So suppose you are going to walk from the starting point dito, going to your destination. So you're going to walk 9 blocks to the right or 9 blocks east and 5 blocks north. So meron kang horizontal component of your displacement and the vertical component of your displacement. The question now is, how do we get the resultant of these two components? So, sa vector kasi, these are considered vectors, di ba? So, meron tayong vector in the x direction and another vector in the north direction. Sa vector, hindi natin pwedeng i-add lang na 9 plus 5 is equal to 14. So, that's the resultant. No, that's not the resultant. We need to consider the directions of the vectors. So, how do we add vectors? So, we can add vectors using two methods. Meron tayong graphical methods and the analytical method. Ang focus natin ay yung analytical method. But of course, we need to look at the graphical method kasi kailangan natin yung principle doon sa graphical method para makapag-solve tayo doon sa analytical method. So how does graphical method works? So the vector addition using the graphical method is what we call the head-to-tail method. No? So these are the steps. Una, draw natin yung arrow. Draw an arrow to represent the first vector using a ruler and a protractor. Kailangan natin ng ruler to indicate the length of the arrow kasi the magnitude of the vector should be proportional doon sa length ng arrow natin, ano? Kailangan natin ng protractor kasi the direction with respect to a reference frame should also be considered. Ngayon, kapag na-draw na natin yung first arrow, ilalagay natin yung second arrow head to tail. Yung head ng first arrow, yun yung tail ng second arrow natin. Ganun yung vector addition. Kaya tinawag na head to tail. Kasi kapag na-draw na natin yung first na vector, ilalapat natin yung second vector, yung head ng unang vector, magiging tail ng pangalawang vector. Ngayon kapag na-draw na natin lahat ng vectors head to tail, pwede na nating isolve yung resultant. How do we solve for the resultant? Ito na, number 6. Ito number 4. Draw an arrow from the tail of the first vector to the head of the last vector. So, magdodraw ka na ngayon ng linya from your starting point to your ending point. Yun na yung resultant natin. Okay, and then gagamitan natin ng ruler and protractor to solve for the magnitude and the direction of the resultant. So, yun. Gagawin natin itong method na to first doon sa example natin on the sa figure natin. So, balik tayo dito. Ngayon, how do we get the resultant? So, na-draw na natin yung first two steps na ito na. Una, i-draw natin yung vector. This is the first vector. Tapos yung pangalawang vector, ito na yung this one is the head, di ba? Ito na yung head ng ating unang vector. So dito magsisimula yung tail ng pangalawang vector which is already drawn. Ganyan lang. Tail, head, tapos kung saan nag-end yung head, doon magsisimula yung tail ng pangalawang vector. Yan. And how do we get the resultant? Yung resultant natin ngayon is a line drawn from your starting point papunta doon sa end point natin. So this is a straight line lang, diretso lang na ganyan. Yan. So that is now our resultant. This is our resultant. Ito yung result when we add the two vectors together. So how do we measure? How do we know the resultant? Kailangan natin ng ruler and protractor. So if we measure yung length ng ating arrow using a ruler, that's 10.3. Tapos using a protractor, we can measure yung theta, which is the angle from the x-axis. That is 29.1 degrees. So ganun lang yung sa graphical method natin. Hindi tayo magfo-focus dito. Doon tayo sa analytical method mag-focus, So, analytical methods of vector addition and subtraction employ geometry and simple trigonometry rather than the ruler and protractor of graphical methods. So, gagamitin natin dito, simple geometry lang at saka trigonometry. Okay? So, dito kasi sa pag-manipulate ng mga vectors, pwede tayong mabigyan ng dalawang klase ng problem, Una is given tayo ng vector, i-resolve natin into its components. Parang given ka ng resultant, gawa ka ng dalawa na vectors na kapag pinag-add mo is equal to this vector. Or the other way around, pwedeng given ka ng vectors na marami, ano ang resultant? Dalawa. So una, yung pag-resolve ng component. Resolving a vector into perpendicular components muna, So, kapag given tayo, for example, ng vector A, kagaya ng nasa figure, how do we solve for A sub x and A sub y? Itong A sub x natin, A sub x is the component of this vector in the x direction. Itong A sub y naman is the component of vector A in the y direction, kaya may mga subscript. Diba? So, ang given natin dito, para ma-resolve natin ang vector into its perpendicular components, kailangan natin yung magnitude ng A tsaka yung theta. Theta is the direction of the vector A. This is the angle resolved from the x-axis, So, kung titignan natin dito, naka-form lang tayo ng right triangle. And when we talk about right triangle, lang naman, di ba? Ang ginagamit natin is the SOHCAHTOA. Remember sa trigonometry natin? Either the SOHCAHTOA lang and the Pythagorean theorem. Diba? So, using SOHCAHTOA, cosine theta is equal to the adjacent over hypotenuse. We'll come up with the value of A sub x. Ito na yung formula natin. A sub x is equal to A times the cosine of angle theta. The same is true for AY. Ang gagamitin lang natin is sine theta is opposite over hypotenuse. So, AY is equal to A times sine theta. So, ito lang yung mga formulas na gagamitin natin. Although, you don't need to memorize. Kapag nakita mo na lang yung figure, use SOHCAHTOA to come up with the components. Di ba? So, ganun. Kapag given tayo ng vector, we can resolve the vector into each perpendicular components. Pangalawa naman, baliktarin natin, when we are given ito yung example natin. Given tayo ng vector, for example, na 10.3, i-resolve natin into its components. Ito na yung A sub x niya at saka ito yung A sub y using itong mga formulas natin na ito. This is an example. Yung pangalawa naman is kapag given tayo ng dalawang components. Ito, given tayo ng A sub x tsaka A sub y. How do we compute for A? Right triangle pa rin ito, tama? So, to solve for A, we are going to use the Pythagorean theorem. A is equal to the square root of the first component squared. Dapat may squared ito plus AY squared. Okay, I'm sorry. I have to edit this one. Ayan, ano? So, ito yung ating formula to solve for vector A. We are just going to use the Pythagorean theorem. To solve for theta, actually, ang ginamit lang natin dito is the TOA. Doon sa SOHCAHTOA natin, di ba? Tangent of theta is equal to opposite over adjacent. So, theta is the inverse tangent of a sub y over a sub x. Okay, you don't need to memorize itong theta. Depende yan kung ano ang given. Pwede mong masolve ang theta using any of the yung mga vector natin na SOHCAHTOA, no? Pero ang usually kasi ginagamit natin is the tangent to solve for theta. So, ayan yung mga formulas natin to solve for the vector, the resultant, given the components. Okay, remember, itong mga formulas na ito, tsaka this one, AX, AY, tsaka itong dalawang ito, they are only applicable kapag yung mga components natin ay perpendicular to each other. Okay, dapat perpendicular yung mga components natin. As an example, we are going to solve this one. Add vector A to vector B. The x and y axes are along the east-west and north-south directions respectively. Vector A represents the first leg of a walk in which a person walks 53.0 meters in a direction 20.0 degrees north of east. Vector B represents the second leg, a displacement of 34.0 meters in a direction 63.0 north of east. So we have two vectors dito, vector A and vector B. And we are going to solve this using two methods. The first one, parehas silang analytical methods. The first one, employing yung head-to-tail method natin. And we are going to use trigonometry to solve for the resultant. And then, yung pangalawang method natin, we are going to use perpendicular components. Okay. So, first na natin dito is using head-tail method. Okay? Pero hindi tayo magpo-foot ruler and protractor, So, head-tail method lang. The method is simply to draw yung vector natin, So, let us draw the vector. Una, vector A. Vector A represents the first leg of a walk in which a person walks 53 meters in the direction 20 degrees north of east. So, ano yung 20 degrees north of east? Remember yung mga four major directions natin. North, east, west, south. So, north of east is from east going to north. Parang magre-recoil lang from east going to north. So, if this is our reference natin sa first vector, yung unang vector natin ay ganyan, So, yung north of east, nandito siya. This is so, this one is the 20.0 degrees north of east yan. Kasi nandito yung east, nandito yung north. From east going north. So, that's 20 degrees. And then, susunod, from the head of the first vector, draw tayo ng perpendicular lines din natin dyan. We draw the second vector, yung vector B. 34.0 in the direction of 63 north of east din. Okay, so at this direction din, pero mas steep lang siya. Ganyan, So, ang 63 degrees, eto na siya. This is 63.0 degrees. Okay, we know, this one is 53.0 meters. And this one is 34.0 meters. And so, nandiyan na yung dalawang vectors natin. So, isolve na natin yung resultant. Ulit yung resultant? The resultant is the line or the vector drawn from the starting point going doon sa last point. Yan. So, this is our resultant R. Okay? So, para ma-solve natin ito, we are going to use This one is an oblique triangle, di ba? This one is an oblique triangle. So, mag-solve lang tayo using trigonometry. Okay? So, una, tingnan natin yung mga, ang kanilang angles. So, if this is 20 degrees, ibig sabihin this is also 20 degrees, right? Alam natin, perpendicular yan, so that's 90. That's 63. So, ang natitira dito, 63, 90 minus 63, ilan yan? 27. Tama? Yan, 27 degrees. So, in total, itong buong angle na to, it's 20 plus 90 plus 27. So, tawagin natin itong theta. No? So, theta is equal to 20 degrees plus 90 degrees plus 27 degrees, which is equal yan, which is equal to 20 plus 90 plus 27. This is equal to 137 degrees. Okay? And then, since given yung dalawang sides natin, we can solve for r using the cosine law. Diba? Cosine law, so r squared is equal to, using cosine law, square, so parang dalawang sides. Hindi ko na isusulat yung unit, 34 squared minus 2 times 53 times 34 tapos cosine of the angle na 137. So, R is, i-solve lang natin yan, 53 squared plus 34 squared minus 2 times 53 times 34 times cosine of 137 degrees. And then, whatever the result, dapat kunin natin yung square root niya kasi meron tayong r squared there. We need to take the square root. So, that's 81.2453 meters. That is our resultant already. Okay? So, the resultant is 81.2453. And then, of course, kailangan natin yung direction. Okay? The direction should be measured, always measured from the x, from the x-axis. Ito yung kailangan natin na angle. So, 20 plus whatever itong small angle na to. So, we are going to use, tawagin natin itong angle na to as, itong maliit na angle na to, tawagin natin as alpha. Yan, tawagin natin yan na alpha. So, using sine law, sine alpha over 34, the opposite side, is equal to yung given na angle, we have sine of 137 degrees is to r, that's 81.2453. And so, alpha therefore is equal to, hindi mo na isusulat, you can, that's 34 times sine of 137 degrees. Tapos, i-divide ko siya ng 81.2453. And whatever the result, lagyan ko ng inverse sign. Okay? Arc sign of answer. So, we have 16.5832 degrees. Therefore, yung angle natin, gumamit na tayo ng theta kanina. Yung angle theta natin, r theta. Lagyan na lang natin ng, theta sub r. Ayan. Para maano natin na this is the angle of the resultant from the x-axis. Siyempre, kailangan natin yan ng 20, tapos i-add natin yung na-compute natin na 16.5832. So, theta sub r is 20 plus 16.5832. which is equal to 36.5832 degrees. So, ito na ngayon yung sagot natin. This is the magnitude of the resultant. R is 81.2453. And this is the direction of the resultant measured from the positive x-axis or measured from the east. Okay? So, we can say, pwede din nating sabihin dito na 36.5832 north of east para mas specific yung direction ng ating resultant. So, that one is using analytical method using the head to tail. Ano? Meron tayong pangalawang method. We call it the component method. Okay? So, the perpendicular component method. We are going to answer the same question. Ano? But this time, we are going to use the component method. Component method. Ano yun? Okay. Una, ano natin yung vector A. Okay. So, vector A. Yung vector A natin is 53 meters. Ganyan siya. Tapos, ang kanyang angle ay 20 degrees north of E. Tapos, ang kanyang magnitude ay 53 meters. Di ba? 53.0 meters. So, kailangan nating ikunin yung component ng vector A along the X and along the Y. Diba? Parang kukuha tayo ngayon ng X-axis natin and the Y-axis. Yan. So, A sub X, this is the component of vector A in the X direction. So, that's 53 cosine of 20 degrees. Diba? 53 meters times cosine of 20 degrees. Yan na yung X component ng A. 53 times cosine of 20 degrees is equal to 49.8037. Kunin din natin yung kanyang Y component. So, that's 53 sine of 20 degrees. Ang pinagkaiban lang actually is the cosine and the sine. Diba? So, ang kanyang Y component ay 53 times sine of 20. We have 18.1271. We'll do the same with vector B. No? Vector B, ang ano ni vector B is 34 meters siya. Tapos ang kanyang angle is 63.0 degrees. Okay? So the same method, kunin natin yung X component ng B. So B sub X is 34 times the cosine of 63 degrees. So we have 34 times cosine of 63. We have 15.4357. And we also have the Y component of B, 34 times sine of 63 degrees. I have 34 times sine of 63 degrees is 30.2942. Yan. So, we have computed for the components of each vector. Diba? So, ngayon, what is the... Remember dito pala sa pag-component, tignan natin yung direction ng vector natin. Yung vector A, ang kanyang component ay positive. Positive X, di ba? Kasi going to the right. Tapos ang kanyang Y component ay going upward. So, positive din ang kanyang Y. So, dapat positive ito, positive din yan. There are cases na magiging negative yung component. For example, kapag downward yung arrow, negative yung Y. Kapag to the left yung arrow, dapat negative yung X. Okay? But in this case, dalawang positive. Positive lahat yung kanilang mga components. Ano? So, positive lahat yan. Kasi to the left, to the right, tsaka upward yung mga arrows natin. Pero just in case na, na to the left or downward yung arrow, you need to make sure that negative yung mailagay natin for the components. Okay? Kailangan natin yan to solve for the resultant. Okay? The resultant, kailangan lang natin kunin yung resultant in the x direction. So, pangalanan natin Rx. Itong resultant in the x direction, this is the sum of all the x components. So, yung AX tsaka BX. So, i-add lang natin 49.8037 meters plus 15.4357 meters. Pag pinag-add natin yan, we have 49.8037 plus 15.4357 is equal to 65.2394 meters. Ito na yung x component ng resultant. We also do the same for the y component of the resultant, r sub y. I-add din natin lahat ng mga y components. So we have 18.1271 meters plus 30.2942 meters. Remember yan, kapag negative yan, dapat minus, kapag nag-downward yung ating arrow. 18.1271 plus 30.2942. 48.4213 meters. So, meron na tayong resultant. Pinag-add lang natin yung mga x components and yung mga y components natin. Now, how do we solve for the resultant? Yung resultant na mismo. Okay? So, for the resultant, R, we are just going to take yung Pythagorean theorem, di ba? So, Pythagorean theorem, yung x component is squared plus y component is squared. And so, yung R natin is the square root of, ano na ulit yung x component natin? X component is 65.2394. So, that's 65.2394 squared plus yung y component natin ay 48.4213. So, 48.4213 squared. So, our resultant is square root of 65.2394 squared plus 48.4213. I have 81.2453. Yan na yung ating magnitude. This is the magnitude of the resultant. For theta sub r, kailangan natin yung tangent, inverse tangent of ry over rx. Inverse tangent of ry over rx. Okay, so, in this case, this is inverse tangent of kailangan nating kailangan din nating pag-isipan. Remember, yung ry is positive. Ry is positive, rx is also positive. Ang ibig sabihin niyan, yung resultant natin, 'di ba, in our cardinal na directions and north, east, west, tsaka south. Kapag positive yung rx, tapos positive yung ry, ibig sabihin, nandito yung resultant natin somewhere dito sa first quadrant, di ba? Kasi positive yung x, positive din yung y. Right? So, ibig sabihin niyan, yung ating theta ay eto, somewhere dito, Itong theta sub r na yan. Okay? Hindi na natin lalagyan kung positive or negative later on. So, lang natin, i-absolute value na lang natin ito. Pero remember, kapag ginamitan ito ng absolute value, you have to take note of the directions of ry and rx dito. Nagkataon lang in this case na dalawang positive kaya nandito sa first quadrant yung ating resultant. So whatever yung theta dyan, ito na yung theta r natin. Ano? So theta r is ry, which is 48.4213 all over 65.2394. Yan. So inverse tangent of 48.4213 over 65.2394 equals, we have 36.583 degrees. Ito yung theta r natin. Okay, para kompleto ito, lagyan natin ng parang directional. This is our theta. Okay? Alam natin na sa first quadrant, yung ating theta, yung ating resultant. Okay? That's how we do it using the component method.